As we come to today, this is our last week on analytical geometry, and I want to start with just a little bit of a recap. So if we look at the main ideas that we need to know about for analytical geometry, one of them is slope of the line or gradient. And these are the different types: a positive gradient, a negative gradient, a zero gradient, and this would be an infinite gradient, a straight up. We also need to know about the idea of rise over run. Okay, so that is that bit there. And if we look down over here, we also need to be able to find the gradient using the gradient formula. In addition to that, we have to also be able to find the midpoint of two things. Okay, the midpoint formula. And then in the last couple of lessons, we were dealing with parallel lines where the gradients are the same, or perpendicular lines where the gradients, when you multiply them, you get -1. Can I zoom in a bit? I can zoom up. Yep. Okay. So I was just showing you like a summary of the section. So let me zoom in. So this shows you some of the different types of gradient of lines you have. Then it shows you how to find the gradient of a line. We also talk about things like the midpoint formula and the distance formula. And then we also need to know about parallel lines and perpendicular lines. So this is kind of the stuff we've been dealing with. And today we're going to remix it all together. So let's start with this question over here. You are given, it says, lines. Can you give me the gradient for the blue one, please? Can you give me the gradient for the blue one? Okay, so we know from the last lesson that the gradient is going to be positive 4/3. And that's because perpendicular lines have negative reciprocal gradients. Okay? But now, I want you to tell me what is the equation of the line B. What is the equation of the line B? So we know the gradient is that. What's the equation going to be? So we know that all straight lines have the form mx plus c. We now know that the gradient is 4/3x. What is c going to be? What's this value c? And in previous lessons, we said, well, we'll just take a point on the line, and the point on the line is 0 to 5. So if we sub that value in, well, the x is going to become 0, and the y will become 5, and so c is 5. And so the equation of the line is going to be 4/3x plus 5. Okay. Now, I want us, we know that the gradient of that one is -3/4. We know that the gradient of this one is 4/3. I want you to help me work out what is this angle over here. We did this in the last lesson. What formula do we need to figure out what this angle over here is? Okay, Bukle, let's go to you. I see your hand is up. What formula will we use?
We use the function tan, so that
Yeah.
and then we substitute the gradient of b because it's the angle of inclination is at b. That's the one we're looking for.
Yeah, so gradient of b was 4/3. And so now we work out what that theta is. That's going to be the yellow angle over there. So I want everyone to work out the angle of inclination that is there. Thanks, Bukle. That was great. Anybody else any questions? Otherwise, pop your answers in the chat. And the lady is given a lovely little tip. You go shift tan 4/3. And what do we get for this angle over here? I want to see a couple of answers in the chat. Callan agrees with Buchler. Anyone else agree with Callan? A lady. Okay, fantastic. All right. So we have worked out that this angle over here is 53.13. Okay, but we're not done yet. I want you to work out for me now what this angle over here is. And that's going to have a lot to do with this line over here. So you've worked out the one down here is 53.13, but now you have to work out what this green one is here. Now it's the same formula, but we have to do something a little bit different. We go equals minus 3/4, that's for the line. When we get our theta, something weird is going to happen. So first of all, calculate what theta is going to be, and it's probably going to be a bit wrong. It's not going to fit what's here already. So what do you get when you go shift tan minus 3/4? So you might get a negative angle, and it looks like you're getting minus 36.87. Yes. Now, the problem is your calculator is not giving you the green one. It's giving you one over here. So what do I need to do to get my lovely angle of inclination, the green one over here? I've got the black one. How do I get the green one over here? So I have to add 180 degrees. And what do I get if I add 180? I get 143.13. And that makes sense because I can see how big that is. Now, that was quite a tough question. Give me a score out of 10 about how you felt about all that, finding the straight lines, finding the angle of inclination. 10 is perfect understanding, 0 is nothing. Tell me how you felt about that question, so I know how much I can, basically how I can choose the next example. And be honest, because remember, your number affects the example that I choose. Okay, so Sanako, it's important that you also watch anything that you've missed from this topic, because we've been building up to this for a while, and so there are some recordings that could be quite helpful. Okay, but don't worry, we've got you. We've got you. We'll make sure you get there. Okay, so here is the next question. It says, the vertices of a triangle ABC are the following. It says, use the distance formula to determine the type of triangle and also calculate the perimeter. So in this thing, there are going to be 3 sides. And those 3 sides are going to be the A to N bit. There's also going to be the N to R bit. And then there is going to be the A to R bit. I will give you the distance formula because it's been a while. So the distance formula looks a bit like Pythagoras, except it's got these parts in it. And I want us to all work out what are the length of all these 3 sides. I'll call this question 1, question 2, question 3. And when you've got your answer, I want you to put your answer for 1, for 2, and for 3 in the chat. And all you're doing is you're finding the distance between each of these coordinates. You don't even have to do a drawing, but I'll do one for you as a rough guideline. But I want you to start this. So off you go, and you pop your answers in the chat when you got them. So, A. So if I'm doing a rough sketch drawing, it would look something like that. Okay, it's been a while since we've used the distance formula, but we can always, it's always good to recap. So -2 minus 8 is -2 plus 8. -1 minus 9 is -10. And that is going to be, I'm going to leave these as surds. So when I say surd, I mean it's non-perfect square that's being square rooted. So I get square root of 1/6. Your calculator can break it down further. But in terms of just showing my workings, we have that. Okay. What you get for n, leave them as just a simple thing like that. I want to know what do you get for NR and AR, and then I want you to tell me what type of triangle are we dealing with. Let's do the second one. NR, so maybe like 7 minus 2, so that's... Okay, so I'm going to give it more time because I think I'm going a bit lost. So I want everyone to do the third one, and then I want everyone to tell me what type of triangle this is. You can do it. So what are we getting for AR? AR, well, I'm going to go from here. So 7 minus -8 is 15. And then 3 minus 9 is -6. What do you guys get for this third one? Dylan, are going to still do functions, but I did, I'm going to put a whole bunch of function resources in the Google Classroom this week from previous year's lessons. In fact, I'll do it straight after this. So straight after this, I'm going to put a whole bunch of video lessons from last year on functions. But we only start functions officially next week. But I know a lot of you are also writing exams soon. So what I'm going to do is I'm going to put those extra videos for you on Classroom tonight so that you can use them for your studying. Okay. Okay, so let's get a look at this. I think this is 15 squared is 225, I think. But I want you to check me, and then you get plus 36. So what are you guys doing for AR? Square root of what? Okay, so Callan has given me the square root of 261. Does anybody agree with Callan? Square root of 261? Can we get a amen or a hell yeah or a definitely? Who agrees with 261? Okay, or 3 root 29. Okay, fantastic. So if we visually look at this, where is AR? So AR is up here, the square root of 261. If we look at 136, right? So where would be 136? That would be AN. This would be square root 136. And then square root 97 would be down here. And what we see is that the green one is definitely the longest one. Okay, and so but they're all different. So triangle ANR is a scalene triangle. Scalene triangle. If it was two sides were equal, it would be isosceles. If all three sides were equal, it would be a equilateral triangle. Okay, now you need to calculate for me the perimeter. Now, all we need to do to find the perimeter is go around the outside. So add up my three surds and tell me a value that you get for the perimeter. What are we getting for that? I want to see some independent confirmation. So put your answer in the chat before even looking, and we'll see if we get the same thing. Pop your answer in the chat there. I only see one answer so far, so I can't be certain it's correct until I see a few more. Aha. Cullen, Quena, Buchle have all spoken, and they have spoken the truth, 37.67 units. All right, fantastic. Fantastic. Okay, let's have a quick look. We've done that type of one here. Before we have a break, let's do this one, and then we're gonna have a break. Show that the triangle below is right angled. Now, there are two ways to do this. The one is the long way, but there's a lovely short way as well. But I want to hear from class, how can we prove something is right angled? The one that I think looks right angled is over here, but I need to prove it. So what are my two choices? There's a quick way and a slow way. Both are correct, but I would highly recommend the quick way. Put your hand up if you're feeling generous. Put it in the chat. What tool would you use to prove that this is a right angled triangle? Okay, I'll give you a hint. Start by working out the gradient between each of these things. So the gradient of PR, the gradient of RQ, the gradient of PQ. So I want everyone to work out the gradient of each of these lines. Now, this one looks positive. That one looks positive. This one looks negative. So I'm expecting this one to end negative. I'm going to say, this is gradient 1, this is gradient 2, this is gradient 3. Find me those three gradients. We don't get the equation already. So the trick is going to be, we are going to use the gradients to show that this is a right angle. And the one that I'm probably going to need is probably going to be the pink and blue one. But maybe we should find the green one just in case. But I suspect it's the pink and blue one that are going to be the most helpful to us. But let's do it. Let's find the gradient for each of these. So PR. Now remember our gradient formula. If you've forgotten it, here's a little helping hand. So the very first one would be 6 minus 3. So 6 minus 3, and then 6 minus 1. So the gradient here would be 3 over 7. So PR, its gradient is just 3/7. Now, I want to know what is the gradient of the blue one? What is the gradient of the pink one? Over to you guys. Okay, so a lot of people are saying RQ is 1. So 6 minus 1. Oh, that's easy. Yeah, so that is 5/5, which is 1. So this one is M is 1. What is the gradient of PQ? I'm guessing it's going to be negative, but who knows? Strange things can happen. So 3 minus 1 minus 1 minus 1, that gives me 2 over minus 2, which gives me minus 1. And that actually makes me very, very happy. Why does it make me so happy? Well, here's the thing. If I say the gradient RQ times the gradient PQ, that is just going to be 1 times minus 1, which gives me minus 1. And therefore, angle Q must equal 90 degrees, or it must be perpendicular, because the lines multiply to minus 1. The lines, you don't even have to write this. You can just use above. Or I suppose, you know what, actually, the correct thing to do would just be to say, to show this, to say, look, MRQ times MPQ is minus 1. So if you multiply two gradients together and you get -1, you know that those two lines are perpendicular. The quickest way to show something is 90 degrees is just to calculate the two gradients and show that when you multiply them together, you get -1, or to show that they're negative reciprocals. There is a longer way. The longer way is to find this distance here, find this distance here, and find this distance here. And after you find the distance, you show the square of the green one is equal to the square of the pink one plus the square of the blue one. And that's called converse Pythagoras, but it takes way longer. And so my recommendation is that we use the gradients to help us show that they're perpendicular. Give me a score of 10, how you felt about proving that angle was 90. Do you understand how to prove two lines meet at 90 degrees using the gradient? Give me a 2 if you don't get it. Give me a 5 if you're in the middle. Give me a... I want to see how you're finding it. What do you think, Danielle? Dylan, what do you think? Sinako, there we go. Okay. All right. I've gone a bit deeper than I normally do, so let's have a little bit of an exercise break. So I want you guys, let me just make sure I spotlight myself. So let us just stand up for a second because we've been working hard, and we're going to stop by just taking 3 deep breaths. And one more deep breath. Yeah, then loosen up your arms. So flap them around like they made of like a sour worm. Shake out your legs. Give them a good shake. You want to really get nice and loose. Get all that tension out of your body from all that hard thinking you've been doing. And then let's roll our shoulders back. Think happy thoughts. And roll them back. And then roll them forward. Then put your arms to the sides. Just make small little circles going forwards. And then go small little circles going back. Okay. And then one more shake. Shake out the arms again. shake out the legs. Okay, then last thing, some high intensity exercise. We're just going to do jumping jacks, and we are going to do 10 of them in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10, and that's it. Okay. I hope that your brain and body are feeling somewhat less intense and that your concentration has been reset. So I want you to solve this problem for me. This is our brain break for today. What is a clock times a soccer ball minus a fan? What do you think that's going to be? What are we going to get here? It feels like this, the soccer balls are quite easy. So they have to be 6, 6, 6. And it feels like this has to be 3, 3, 3. So those aren't hard. What is hard is this blue funny fan thing. What's this going to be? So I'll put that in there, and I'll put this in here. But I need a bit of help with these fans, or whatever they are. Three times. Oh, thank you, Callan. That's very helpful. And Dylan, thank you very much. So these are also 3. So what is my final answer going to be? What is my final answer going to be? Oh, there we go, Dylan. I think I agree with you, because this on BODMAS, it has to be this. And the lady agrees. So I'm feeling pretty confident about my answer. Okay. So 3 times 6 minus 3. Oh, Anushka agrees. So I'm feeling very confident. Okay. Let's get back to the second half of the session. Let's have a look. Ooh, this is a proper interesting exam type question. Now, let's start with, we're going to go through questions like this in this lesson and on Friday, but let's start with 2.1. I want you to find me the coordinates of the midpoints of AC and BD. So AC is that line there. BD is that line there. You need to find me, to start with, the midpoint of AC and the midpoint of BD. What I will do to help you is I will give you the midpoint formula down here that you can use. But over to you guys. I'm going to get some water, and then I'm going to come back. I'm going to explain what this means. So I get a midpoint, and so does Lady, so does Buchle, of 1, 0. So the midpoint of basically this one over here cuts this line in half. And that point is the point 1, 0. What is the midpoint of BD going to be? What is the midpoint of BD going to be? Something interesting is happening here. So I agree with Kellen. Like you basically get 2 over 2, which is 1, and Anushka as well. So what we find is that the diagonals bisect each other. So diagonals, I'll explain what that means now. Diagonals, or we can just say bisect. And what that means, it doesn't mean that the diagonals are equal in length. You can clearly see that the green diagonal is way longer than the yellow one. But what we do have is this common midpoint. And what is that common midpoint? It is 1, 0. So if you find that the diagonals cut each other in half, we say that the diagonals bisect each other. And that's one way of proving something is a parallelogram. So even though it didn't ask you this, okay, it asks you in 2.2. Okay, let me answer. So we did 2.1 here. 2.2 says, what can you deduce from answers in 2.1 about the diagonals of the parallelogram? They cut each other in half, or the diagonals bisect each other. And if diagonals cut each other in half or bisect each other, you then know that the quadrilateral that they're forming, therefore ABCD is a parallelogram. Now that's a little bit weird, and I'll talk more about it in the next lesson. But basically, if you can show a quadrilateral has diagonals that cut each other in half with common midpoints, it will be a parallelogram. And it's probably the easiest way to show something is a parallelogram is to show the diagonals have a common midpoint. Okay, let's have a look at the next bit. It says, calculate the gradients of AC and BD. So you are going to find me the gradient of AC and the gradient of BD. And I'm going to put them in the colors that they were using already. So BD was the green one. But this time, it's not midpoints, it is gradients that you're looking for. So over to you guys. Find me the gradients. I'm guessing the yellow one should be negative. I'm guessing the green one should be positive, just from looking at it. Can we remember our gradient formulas? So 2 minus 2 over 0 minus 2 would be 4 over minus 2, which would be minus 2. What do you get for the gradient of BD? So I did the gradient of AC and it's negative. So that makes me happy because I feel like I understand what's going on. I'm hoping the green one will be positive. Ooh, I wonder what that means. So 3 minus 3 over 3 minus 3 over 7 minus 5. which equals 6 over 12, which equals a half. What do we know about the relationship between these two gradients? It's ringing a bit of a doorbell. It looked to me like 2 minus 2 could be written as minus 2 over 1. So what is the relationship between the green line and the yellow line based on what we see here? Yes, Peter, exactly. They are perpendicular. So you know that calculate the gradients and see what the relationship is. Well, we know that AC is perpendicular to BD, and the reason is the gradient of AC times the gradient of BD equals -1. So we can pick this up by just seeing that we flip the 1 over and change the sign. But basically, these diagonals are at 90 degrees to each other. Okay, now here comes an interesting question. I said to you earlier on that ABCD is a parallelogram, but it turns out that there are actually lots of different types of parallelograms, and you can have a specific type of parallelogram. Normal parallelograms don't have diagonals that meet at 90. Okay, so what do you think the type of parallelogram is this one going to be? Where the diagonals cut each other at 90. So if the diagonals cut each other in half and they cut each other at 90 degrees, it's not just a normal parallelogram, it's actually going to be what we call a rhombus. So again, I will talk more about this in the next lesson, but this will be called a rhombus. If you've got diagonals that bisect each other at 90 degrees, it's called a rhombus. Talk more about that in the next lesson. Okay, almost the last question for today. Find me the equation of the line AB. And then after we've done that, we call it a day for today. So find me the equation of the line AB, which is the yellow line. It's not even the yellow line. Sorry, AB is this line over here. It'll be a pink line that goes like that. So I'm going to rub away all the other stuff, and I want the equation of the, and I think we're going to call it a day for today. And then the last lesson on thing we're going to use, we'll go into more detail with exam questions. What's the gradient of AB? So if I look at AB, I'm going to say 2 minus -3 over 0 minus -5, which is going to be 5 over 5, which is 1, which gives me y equals 1x plus c. All I need to do now is I need to figure out what c is. And if I look at this, the easiest point to sub in to my straight line is the point 0, 2. But I noticed something else. I think that there's something special about this point, 0, 2. What is special about the blue point? Yes, Bukle, let's go to you. So what is special about the blue point, Bukle, that you got that so quickly?
It's the y-intercept, sir.
Yep. And so if it's the y-intercept, do we really need to sub in the point 0, 2?
No, sir.
Okay, so you basically know that C is the y-intercept. So did you just go, okay, cool, I'm going to write a 2? Is that what you did?
Yes, sir.
Perfect. Awesome, 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 awesome. Okay, everyone, that is our lesson for today. In our final lesson on analytical geometry, we're going to finish this question, and then we're going to look at more kind of exam questions to do with parallelograms and rhombuses and maybe like a square. We're going to look at different types of quadrilaterals that we can get. And so that's what's coming up in the last lesson of this section. I'm also going to put